metric tons of oil equivalent on the y-axis, and then looking at a couple of decades, simply to say a couple of things. One is that we do see biofuels playing a much larger role going forward than they are currently today, but also that oil-based materials will still play a very significant role going forward in the near term. But we also see more of a diversity even amongst the oil choices, and that's some of the things we talked about already with the first couple of speakers. Synthetic fuels, unconventionals, etc. Okay. Now, what about these environmental benefits that biofuels can offer, and how easy is that to implement? So this is kind of a notional look at a lot of the options that are out there. So conventional gasoline and diesel, already in the marketplace. How easy are those to implement? Anything that may come along, and what is the benefit both from local emissions and climate change CO2 type of issues? So you look in the middle on bioesters and diesel and ethanol and gasoline, fairly easily to implement, and there's some benefit that's quantifiable, measurable on CO2 climate change reduction, so the CO2 footprint. What we'd like to get is further out, up into the upper quadrant, biomass to liquids and diesel, where much more significant reductions in the CO2 footprint can be realized, and also cellulosic ethanol and gasoline. I won't say much about hydrogen because I think that's going to get covered very well here in a little bit. So these are some of the options available. That's why we're looking much more towards second generation biofuels. I like this one because it really shows, kind of puts it all together for first and second generation biofuels. If we look first at ethanol from food sources, so it could be, we're looking at in this circle, could be sweet corn, sugar beets, sugar cane, whatever. You take the fermentable sugars and starches and take those through a process and make ethanol to blend with gasoline. And then on the biodiesel side, we're talking, of course, about seed oils. Canola, rapeseed, soya, palm oil, is any number of varieties. It could even be animal sources, whatever the case may be. Again, those can be esterified. You can make a biodiesel that's liquid, compatible with current vehicles at normal concentrations, low concentrations. And we can do all that now, but we'd like to get to the bottom. And we want to look at how can we make use of other parts of the plant that haven't been in the past, that's available. We can take those, and hopefully there are processes where you can go to the same types of products, or even better products, using the waste material. So we take, for example, the plant stock, grasses, whatever, types of cellulose materials, make ethanol that we can blend with gasoline. On the diesel side, we would like to be able to take the plant material and gasify it, as Sylvia was talking about, and make an analogous product that's being made with gas to liquids. Take it through some kind of process, Fischer-Tropsch, Shell middle distillate series, and make a really nice diesel fuel, for example.
Aren't some of the folks who are looking at second generation ethanol looking at gasification as well, not just enzymatic hydrolysis?
I believe I have seen some of that talked about, yes. Yeah. Okay. Now, Shell is working very closely with a Canadian company called Iogen, which some of you know about. I shared that hijacked van this morning going to Starbucks, and we talked a little bit about that this morning. And, of course, this is looking at cellulosic ethanol, processing straw to cellulose or some other types of materials, switchgrass. We're looking very closely at what some of the feedstocks might be. It's moving along. There have been some challenges. There's some more work to do. But if we start talking about wheel-to-well CO2 footprint, so as Sylvie was saying, she was talking about wheel-to-tank, and now you look at the whole life cycle. So where does it feedstock come from? How do you grow the plants? What kind of energy is used to go through that process? And then transporting it, making the fuel, and actually burning the fuel. We believe there's some very significant benefits that can be achieved by doing it that way.